Now what about g of f of x? Well, g of f of x equals to what? Well, let's see. We had a function f here, and we had a function f right here. So we're supposed to take this entire function f and replace all of the x of the function g with that. So that means we are going to have 1 over, instead of x, I'm going to have this chunk right here. So x over x minus 1, and then plus 2. And of course, finding a common denominator by recognizing the fact that 2 by itself is the same as 2 over 1, and the least common denominator in this case is x minus 1. So multiply this denominator and numerator by x minus 1. That means we are going to get x over x minus 1 plus 2 times x minus 1 over x minus 1, and then keep the 1 on top. So this is going to give us still the numerator 1, x plus, well, let's see, we got a positive 2 here. Distributing the positive 2 into the x minus 1, we are going to have 2x minus 2 all over x minus 1. So combining like terms, x and 2x, we are going to have 1 over 3x minus 2 over x minus 1. And 1 by itself here is the same as 1 over 1. The fractional form is basically the division, standard division form with the division symbol, divided by 3x minus 2 over x minus 1. And then a fraction divided by another fraction. Keep the 1 on the left, flip the 1 on the right to come up with its reciprocal, and then change division to multiplication. So we got 1 over 1 multiply x minus 1 over 3x minus 2. So that is the same as saying it's x minus 1 over 3x minus 2. So what is, can we simplify this any further? No, we cannot. So we are going to go ahead and try to find the domain of it. But before we can even do that, we have to go back to every step and find all of the restrictions. So at this step, the result here, we know the restriction is that x cannot be equals to 2 over 3. Okay, so oops, actually no, let me write it like this. 3x minus 2 cannot be equal to 0. Add 2 to both sides, we get 3x cannot be equal to 2. Divide both sides by 3, we get x cannot be equal to 2 over 3. Like that. So this, the result here, the resultant function has a restriction of x cannot be equal to 2 over 3. What about this step? Well, the same thing. This denominator, x cannot be equal to 2 over 3. What about this step? X minus 1 cannot be equal to 0, so x cannot be equal to 1. Same thing for this step. Well, actually, same thing for this step. X cannot be equal to negative 1. And assuming that this denominator is not 0, so if this numerator here is 0, we would have 0 divided by a non-zero number, which would make this whole denominator become 0, which would make this whole thing undefined, which would make the entire problem undefined. So at the same time, we have to say that x cannot be equal to 2 over 3 for this step. And this step's, this step can like the same thing. X cannot be equal to negative 1, and of course this right here, x cannot be equals to 2 over 3. Right? I mean, combining that term, and you'll get back 3x minus 2. So up here. At this step, was the same thing. X cannot be equals to positive 1, and X cannot be equal to positive 1. Okay? And well, I'm not going to say that X cannot be equal to 0, because this step is basically this step as well. So we had a common denominator, we combined it into 1, so you know, this step is equivalent to this one, so I'm not going to do anything with that. And of course, the first step right here, X cannot be equals to positive 1. And of course, I'm not going to do anything with this because this step is equivalent to this, which is equivalent to that. Right? So for every step, we have all of the restrictions of X cannot be equal to 2 over 3 and X cannot be equal to 1. Now, what about a step where we input the function f? Well, more specifically speaking, what is the domain of the inner function f of x? Well, let's go back here. The domain of the function f of x is that all real numbers except x cannot be equal to positive 1. So let's say all real number, hashtag, which is numbers, and the same thing right here, all real numbers for the function g. So yeah, so for the inner function f of x, the domain is all real numbers except that x cannot be equal to positive 1. So taking into consideration all of the restriction of the inner function and all of the restrictions of every step of the simplification process, we know that the domain of the entire composition of function g of f of x is all real numbers except x cannot be equals to 2 over 3 and positive 1. So what is the interval notation for this? Well, same thing, sketch number line. From left to right, negative infinity to positive infinity. Let's just say 2 over 3 is here. Let's say positive 1 is here. So going from left to right, we are excluding these two values. So going from negative infinity to up to 2 over 3, but not including it, the interval notation for this part is going to be an open parenthesis, open interval from negative infinity, comma, 2 over 3, not including it, of course. Jumping to the next part, we put a u inside. Still, we are going to have a parentheses at 2 over 3, going all the way up to positive 1, but not including positive 1, like that. Going to the next part, from here all the way to positive infinity. We are going to put the u inside. I'm going to put it here so that it's easier to see. Moving from 1 to positive infinity. So yeah, this is the interval notation of the domain of this composition of function.